This is Geometry, Chapter 12, Section 6, in which we'll be studying surface areas and volumes for spheres. And remember, a sphere is like a ball. It's three-dimensional, circular type animal. To find the surface area of a sphere, it's 4 times pi r squared. And to find the volume of the sphere, it's 4/3 times pi r cubed. Okay. In and of itself, spheres or calculations with spheres are not that bad. Okay. The hard part is drawing them, believe it or not. So we're going to find the surface area and the volume of a sphere, and they tell me the diameter is 22. Well, if the diameter is 22 feet, that means the radius is 11. And the radius is the key number that I need. So surface area would be 4 times pi times 11 squared. Punch that in your calculator and get a nice answer. Volume is 4/3 times pi times 11 cubed. Punch that into your calculator. Okay. Working on those ideas, very straightforward, simple, plug and chug and go. Now we're also going to plant some seeds here for you to get you thinking about something else, something that will come up in the next lesson. If I take a sphere and I have a plane intersect with that sphere, I have two choices. I can have a point be the intersection, or I can have a circle be the intersection. Okay? Picture, if you will, an orange. And picture, if you will, a knife. Now, if I put the knife against the side of the orange, not cutting into it, but just up against it, that knife is tangent to the orange, and it's touching it in one point. Now, if I take that same knife and I move over a little bit and I slice through the orange, and then I look at what shape is there from slicing through it, I'm looking at a circle. Okay? That's the idea of what's going on here. It can either be up against the side of it, so it's tangent, or it can cut through it, at which point we get a circle. Now, if the plane happens to go through the exact center of the sphere, then the circle that you get is called the great circle. It's the biggest circle you can make out of that sphere. And when you have the great circle, you cut the sphere into two equal parts called hemispheres. Okay. Now, we like to find surface areas and volumes for hemispheres as well. The volume of the hemisphere is half the volume of a sphere. That would make sense. The surface area is not really quite half. It's more than half because the outer part of the hemisphere is half of the surface area of the sphere. Plus you have that circle, that orange piece that you cut off there. Okay. Yeah, great. I'm waving my hands at you and you can't see them. Boy, I tell you, some days. So we have a couple of formulas that we can use with the hemisphere. And if you don't recall these formulas when you get to them, I can show you where they came from. Because you can't see my hand waving right now, but it's really cool. So let's find a volume and a surface area for a hemisphere. And be warned here, they're throwing a curveball at you already. The great circle has a circumference of 36 pi. Now remember, I'm going to jump back a page, we need to know the radius to be able to do any of this. Okay. Well, we don't have the radius here, but we can find it because circumference equals 2 times pi times r. Substitute the 36 pi in for the circumference and divide, and now we know our radius. And knowing our radius gives us everything we need. Okay. The surface area is, according to the formula, 3 times pi r squared. Punch that in. And the volume, according to the formula, is 2/3 pi r cubed. And we'll punch that in and get some really funky numbers, but that's okay. And as always, your mileage may vary a little bit if you use 3.14 instead of the pi button, or if you round it or chopped or whatever. You might have a little bit different answer. As usual, the neighborhood rule is in play. So fairly straightforward stuff. We like spheres because they're easy. There's only one number involved in it, and that's the radius. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.